There has been some changes. We will have now the second keynote of the conference, presided by Sam Aaron. And I let you. And then after this, we will have the poster sessions. So, Sam, please.
Hello, is this what? Oh, very loud. Hello. It's funny to hear your voice in the microphone. Super happy to be here. Thank you so much for having me. It's a real honor to be in this environment, in this community. I was at the first one in Leeds, and I had a really lovely time. It's lovely to be here as well. So, and unfortunately, I'm about to run away when I finish this talk, so I've got my flights, because I promised my children I would be home for the weekend. So if anyone has any questions that we can't answer at the end, I'm very happy to talk to you offline or online afterwards. So please feel that you can ask me any questions you want during the talk as well, and after the talk, and then when I've gone, you can still contact me and ask me any questions you want. So I'm going to talk really about lowering the barrier to entry, not just for live coding, but for coding in general. And I'd like to talk to you about what I've learned through my processes and how that might apply to yours as well. Because for me, for sure, a lot of these things I'm about to talk about were a complete and utter surprise. Like, I had no idea that the benefits were going to be so profound to the simple choices I'd made. And maybe they might have some benefits to you, maybe not. And it's really important to have a bit of an open mind and explore these things. And so, I'm not even moving and it's gone away. Thor's given me another adapter. It's my third adapter. Let's try this. It's back, right? Okay, well, it might just come and go. Okay. So, look at this, beautiful. Projectors still haven't been fixed, have they? Like, it's still the weakest link. Let's try the Thor. Come on, Thor. Are we going to work? See, maybe my computer is dead. I don't know. Apparently there was a very much more complicated setup that we're working on, and mine was going to be very easy because I could plug my laptop in. So, okay, let me just talk about, without the screen, it's going to be very hard, but I can just talk. So, in the early days, I was working on a system called Overtone. This is quite a number of years ago. And this was a system which was very much, I think, in the spirit of the kind of live coding systems we're all using. So, it was a bespoke system made by myself and my friend Jeff Rose, mainly for myself, and exploring what I could do, and taking a very much a traditional programming perspective. So, what is the most powerful language I could possibly imagine, and I would attempt to build something towards that. So really thinking in terms of programming languages, and in terms of abstractions, and power in terms of what could I... you go for it, have a play. What can I do in terms of power of languages? And Overtone really was an exciting place for me to learn lots of things, and I really did a great job in my own mind, in the sense that I was able to create a band and perform around the world with it, but it had a real a negative side effect, which surprised me, which was I did a performance in an arts festival where I got a really nice review. And the reviewer said this performance was interesting, the audio was great, there was homage played to all these musicians which I'd never heard of, so I'll take that for free. And at the end of the review, the person said, great visuals. I'm like, you totally missed the point, right? Because obviously we all know that the text isn't the visuals, it's the instrument. You know? And so this reviewer was unable to perceive. Has someone else got a laptop that I could use? I mean, I've never had an issue with this. This is so ridiculous. So I've got in my head what I'm going to say, and it's going to be pictures next to it, so I'm speaking now. So the Overtone thing was about power, but it was also about myself. It was a selfish kind of thing. I'm building a language for myself. But what it meant was that people couldn't really understand it. And this review where they said great visuals, it was a sort of a kick in the teeth, because that wasn't the visuals, it's my instrument. It was a bit like going to a Jimi Hendrix concert and the reviewer saying, great wooden medallion. alluring to his guitar. If you don't know what a guitar is, what on earth do you perceive that wooden object around Jimmy's neck? And obviously we get that all the time with live coding. So that was an issue. And then also I would go to Clojure conferences. So Overtone was written in a language called Clojure. And I would speak to the professional Clojure people, and they would get super excited, and they'd say, yeah, I can now, because I can program Clojure, and you've made a system that can turn Clojure into music, I can now become a musician. And so this was like the promise. And I remember walking, after I gave a talk, in the hotel, walking down the corridors, hearing all these crazy sounds coming from all the rooms. So obviously all these developers had booted up Overtone and were making sounds. But absolutely none of them really progressed, maybe 3 or 4 in the world. And so for that was also, for me, was problematic in that, although I had created a system which I was happy with, which I felt was powerful, that I wanted to spend the rest of my life, really, at that point, working on developing, no one really understood it, no one really could use it, no one really was able to progress with it, and the number of people who even could just install it was basically 0. Okay, it's not 0, we were talking about hundreds of people, but 100 divided by all the number of people in the world is not that many people, it's essentially 0. And so, I mean, it's probably more people that can see what's going on the screen. So this was growing in my mind as a problem. Because really what I wanted to do wasn't really to build an instrument for me, it was to build an instrument that everyone could play if they wanted to. And I wanted to build an instrument that, even if you've never seen the code before and you went to a concert, you would have some way of getting inside the code if you wanted to a little bit. In the same way, if you go and see a Jimi Hendrix concert, well, I wish I could, but if you could go and see a Jimi Hendrix concert, you could see some elements of his virtuosity by observing how fast his fingers and how precisely his fingers were moving on the fretboard of the guitar. And that was a really, what is going on with this laptop? Sorry. Is it a resolution issue?
I think so, yeah.
Yeah.
I mean, I was able to fix it by changing my resolution.
Oh, right, yeah. So scale it to like 224 by...
I've tried a bunch of different ones, but
yeah.
Maybe you'll hit the magic one.
No, sorry, and then you need to switch it over. I'm going to give a keynote with no slides and no music and no... This is brilliant, so you may as well leave. Okay, let me just back up. So I had created this language called Overtone. It was really mainly for myself, and other people couldn't use it. And this became frictionful and problematic to me. And then, hey, along came the, let's not touch it, the Raspberry Pi Foundation. So, yeah, let's just, hold on. Right, if this is working, I can actually show you some things. So, this was Overtone, and this is the system I was working on. And this is the band I created. And we went and did a bunch of performances, we had a lovely time, but again, no one could understand what was going on. And then along came these people, the Raspberry Pi Foundation, and they span out of the computer labs at Cambridge, where I still currently work. And they had this problem, right? It was a good problem, that they had made this computer, and it was selling like hotcakes. Like really, they've sold over now 15 million or something, ridiculous number of these computers. And in the early days, that success was a problem for them because they were promising to teach children how to code. And they had the hardware, which was really selling very well, but they didn't really have much software which ran on the Raspberry Pi 1, which was the original Raspberry Pi. It was a very, very low-powered computer. It was very cheap and affordable, but also very low-powered. And so they were then like, oh, we've got this really successful product. How on earth do we get kids to code? And so they went around, the chip manufacturers, this little chip here is called Broadcom, and they had a small bunch of money, like 3 months of funding, to give to someone who might be able to build some sort of thing which might engage kids in programming. And that was sort of somehow ended up on my desk, and someone said, maybe Sam, you could build some sort of music-y thing. You've been working on this Overtone stuff. And I said, I'm pretty sure I could simplify that down to something on the Raspberry Pi. And so that's what Sonic Pi was, and it took me 2 weeks to build the first version. It was super simple, and all it did was like play note 70. Can we have the audio, please? And sleep for a second and play note 75. And that was it, right? That was the first version of Sonic Pi. The sleep wasn't well timed, it was terrible, but it worked. And I was able to go into a lesson and teach sequential programming, because we were teaching computer science, right? So line 1 before line 2 before line 3, so there's an order as it goes down. And then I started adding other features which were specific to teach computer science, so like how do you do iteration? let's do that 4 times, you know, and sleep for half a beat there. This kind of thing, and conditionals and functions. I'm not going to spend much time looking at this. Many of you might have looked at this already, and the tutorial has all these things. But what was interesting to me was this thing here, as you can hear, was clearly not going to be the tool I was going to use to perform live on stage. Right? It was a tool, it was a toy for teaching children how to code. And it turned out to be really fun and successful, and the kids liked it, and so I kept adding more features and making the timing correct and adding the ability to play samples. Let's play an ambient choir like this, or change the rate to half speed, and like this, and like mess around with these kind of things. And these are all fun things which allowed me to broaden the engagement in computer science with these students. Because the main problem in computer science, well, there's 2 main problems teaching computer science. One is there are not that many teachers currently that have the skill set, because most programmers who graduate go and be professional programmers, and teaching is currently a very, very difficult subject to work in because of all the, certainly in the UK, the constraints on teachers is crazy. The number of examinations and things that they're tests and stuff. And also in the classroom, I don't know how many of you have been in classrooms recently, but the amount of time a teacher has in the classroom to explain anything is essentially 0, right? So if you're going to open up Emacs or Vim or Eclipse or any of these like large professional grade developer environments, Xcode, that's already 5 lessons just opening it up and starting a project because you have so little time. And also you've got the fact that most students have already decided that they don't like computer science, it's not for them. Especially women from teenage years onwards, I found that most of them made their minds up, and this is problematic. And so, finding ways to actually make it really simple with a short amount of time, and also to make it engaging and meaningful, was ways to solve both of those problems. And so, I had to then think about how do I make sure that all the features that I put in pass those tests. So I call it like a 10-year-old ready test. So every feature in Sonic Pi has to be simple enough that I can teach to a 10-year-old child. And that was there originally because I was teaching it to 10-year-old children, so that's obviously what you're going to do. But it turned out that a lot of the decisions I made in attempting to get that simplicity turned out to be super useful for me personally and also for others. And these are the things I'd like to talk about. I think for me, this is a real surprise. So going back, so I built this Sonic Pi. It was a very simple toy. I was still doing this MetaX thing and performing around, playing with overtone, having a lot of fun. And then 2 things happened, quite dramatic things happened. One is that Jonathan Graham, my brother-in-law, moved to Chicago from the UK. So we were meeting each other every week and performing together in a bar or in a cafe and just jamming and playing. And so that allowed us to practice and keep going. But obviously when he moved to Chicago, that killed really that ability to have the band still running. And also, at the same time, I got a commission from the Arts Council to make a music video with Sonic Pi, running on the Raspberry Pi 1. And actually, now that sounds like an exciting proposition, but then I just didn't want to do it. Because Sonic Pi was a rubbish toy, and Overtone was my sort of professional, exciting, exploratory vehicle, and that's where I wanted to put all my energy. And I was doing Sonic Pi just to earn a living, essentially, and explore things, but I was secretly making all the synthesizers in Overtone. I was secretly having an idea of being able to take the ideas in my work and porting them across to Overtone, where I thought I was going to spend a good chunk of the rest of my life focused in. But anyway, this video, the deadline loomed, it came closer and closer, and I was putting it off, and then I just sat down for a week and said, okay, I'm going to do this. And it had to run on a Raspberry Pi 1, and I'd seen other people working on projects where they'd got a prototype of their project running on their Mac, running on their PC, and they ran it on the Raspberry Pi 1, and it just didn't work because the Raspberry Pi 1 was so underpowered, everything just stalled and it was slow. So I knew that to make this work on the Raspberry Pi 1, this composition I had to write, this music video, I had to actually compose it on the Raspberry Pi 1. So that was like the constraint. So if I compose it on the Raspberry Pi 1, of course, then it would work on the Raspberry Pi 1. And I also had to make a music video, and actually this is the video here I'm about to show a little section of. And I've never made a music video before, or a video, really. And so how on earth do I do this? And so my simple thinking was, I'll basically spend the budget from the Arts Council and buy two things. One is a video manipulation suite, so I bought that. And the other one is to buy a mini portable projector. So my idea was I can project the code on various parts of the buildings and the sea and columns, and then make a montage of those as my video. And so I then sat down in my living room to code this piece of music on this Raspberry Pi, and then I realized I don't even have a monitor at home because I've just got a laptop. How am I going to see the Raspberry Pi? Because in my office at work, I had a little monitor I was using, and I wanted to sit on my own for a week in my house and just compose this piece of music. So, of course, I got this little projector. So I was using the projector on the wall in my living room. And actually, let's just show you some of this video. You can see what's going on. So here we are, I'm projecting the code on the sea. In a moment, you're going to see the place where I actually did the composition of this piece. Transitions. So this is it. I was using, this is the Raspberry Pi, there it is. I was using a standard keyboard. There's my hands running the code. I was using like a sewing machine as a stand. There's the projector, there's some speakers, and there's the code on the wall, right? And let's not stop and listen to the whole thing. That's essentially how I worked for a whole week. And this, I'm talking about this because this completely changed my life. In ways that are still profoundly affecting me. The main thing is I got out of the computer, I got out of the screen, and I got out of my traditional programming environments. I wasn't using Emacs, I didn't have Twitter, I didn't have the web browser. It was just me and the music code big on the wall, and I felt inside of it. And that just changed, and since then, all I did, the only way I worked with Sonic Pi was to project it on the wall. It just, putting it inside the screen on a laptop just felt wrong. It felt constrained. It felt like programming. It didn't feel like making music. And also, the other thing that profoundly affected me is because I had to then make this piece in Sonic Pi, I actually learned that a lot of the features I had developed for school children to make the system simple turned out to allow me to express my thoughts much, much, much more rapidly than I could in Overtone. And this is a point I try and talk to professional programmers about, because I think there's something that maybe you guys are completely understand this. It's natural for your way of thinking. But professional programmers typically don't tend to talk about time. And obviously time is a fundamentally interesting and folded and beautiful concept. But in programming languages world, time is really about efficiency. How long does my algorithm take to execute? Is it polynomial time? Is it fast? Is it slow? And that's what people care about. And obviously, when you're making music, faster is a different music, right? You don't want your computation to go faster. You want them to go on time. And so that style of time wasn't actually what I was thinking about. What was important. What was important really was how long did it take to get an idea from my head into code, into sound. And by making a very simple system for school children, it turned out that process was, for me at least, was fluid and incredibly quick and surprised the hell out of me. And there's a big difference between a language which is powerful, which allows you to do lots of things, like SuperCollider has this property, Overtone has this property, Extempore has this property to levels beyond we can imagine. These are beautiful languages where you might imagine a thing and spend a week or 2 weeks or a month building a beautiful instrument out of these concepts. And that's a completely different way. That's a timeless way of building, where the amount of time it takes you to build the thing is just, it's not really a critical thing, unless you've got a budget or something. But obviously when you're performing, time is a very different thing. It's how long does it take me to get the next thing out? And we talk about this all the time. I'm not telling you anything new. But for me, at least, sitting here in front of this projector, it blew my mind. Like, this is a language which was less powerful, but was simpler to work with and quicker to work with, turned out to be way more powerful for expression, rather than powerful in terms of what you could build as a programmer. And that, for me at least, was much more meaningful and resonated with me much more internally and beautifully. At this point, I never went back to Overtone again. Never spent another moment developing it. That's why, when this thing is just much more fluent and creative. So that moment really for me was a crucial thing. And focusing on simplicity was really what led to that. And also coming away from the screen, coming out of the computer also led to that as well. So I think that's really, I challenge you to just sit at home and get a small projector and just put it on the wall and use that for a few days as your practice environment and see if that helps you or doesn't help you. It certainly radically changed things for me and made me perceive programming in a very different way and the act of programming. Does it make sense? I mean, you're all sitting there very nicely. Thank you very much for that. But obviously, if you want to, you can ask questions at any point. I'm very happy to be diverted to wherever direction you want to go. I'm not like the traditional academic that wants to wait for questions at the end. Ask questions, make comments whenever you want. Shout, whoop. Okay, so does that make any sense? Like, for me, that was new. Maybe for you, that's completely sensible. And then from that point on, it was very clear to me that there would be benefits if I added features to Sonic Pi that were useful for me as a performer, but also passed this 10-year-old ready test that I was already implementing because I was in school. But it turned out all these features that are simple work well in a constrained, difficult, tense, pressurized environment like a nightclub. And so this was all these features made sense to me and really allowed me to build something that not only was a performance tool for me, but was something that other people could much more readily and much more easily play with. And that for me was really where I got my joy and the beauty of things. And so like even features like this, right? So if we all know like the Amen break, yeah? Now, one of the things, obviously, people did in the 90s was to slice it up. People have done this. Neil did that performance, which I wasn't. I was buying a beer, sorry, but which was amazing. He gave me a demo this morning. So this is obviously not new to you, but my question was, how do I get slicing the Amen break up in a way that 10-year-old kids could do, right? That was the challenge. And it took me a year. It took me a whole year to come up with this, which is the onset option, right, where wouldn't it be great to treat a waveform as a list of hits, of drum hits? So I can just walk through each of the different drums in the Amen break as an index. And obviously this does some feature detection of the audio file. It returns all the timestamps of where all the drum hits are, and then I can then walk through those. Then of course, all I need then is a loop, and I can sleep for a short amount of time, and I can obviously then play that drum, or this drum, or this drum, or pick a random drum. Right, and this is something you can show to a child, and like, wow, that's amazing, and they can understand this, and it's a beautiful thing to see. So things like this were features I wanted to add. And then also, one thing which surprised me as well is like, there's a loop there, so let's put that aside. I need to comment this out. Yeah, let's make another loop. Let's play the bass drum kick. See for half a beat. End. So we now got a kick drum, right? So within pretty much all Sonic Pi workshops I've ever done, within an hour and a half, this is code that all the children have. Obviously, they might not be picking the onsets, but they certainly have 2 loops or 3 loops. And the one loop is doing bass, one's doing drums, one's doing a melody, all sorts of it. One's doing like a drone. And then they run this code, and they put their hands up, and they say, teacher, why am I not hearing the drums at the same time as the kick drum? Like, where is the Amen break gone? Where is the Amen break? Right? Now, if you're a programmer, you might have a good understanding of why you can't hear the Amen break. So here's, from a teacher perspective, here's an opportunity for learning. Right? We can teach the fact that loops are black holes for the program. The programmer gets into this loop here and stays there forever, right? It doesn't ever escape. So you never get down to this loop ever, right? And so from a teaching perspective, this is great. Here's an opportunity to teach how single-threaded programs, once they get into a loop, stay there forever. Beautiful, lesson done. But of course, a child is not asking you to explain loops and single-threaded programs. They don't give a monkeys about that stuff, typically, unless, and this is a really big unless, and this is where we need to be very aware, that often when you speak to other people teaching people, whether it's programming or creative programming or live coding, often the people who are doing the teaching are utter weirdos, right? I'm a weirdo. Most of you are weirdos. In the sense that, sorry, but you are, right? Because you've all found programming, most of you have all found programming in your own natural ways, right? And found it, and maybe someone told you about it, or you discovered it, and then you spent the time yourselves, most of you, I'm sure, sitting in front of screens, figuring stuff out patiently, carefully, understanding stuff over time. Most people haven't done that and don't want to do that, right? So, and I think if we want to reach a broader set of audiences that aren't the kind of people who would naturally themselves come to programming, like most of us have, we need to find ways that we wouldn't ourselves be interested in. And so this is an important point. So most of these children don't really care about how does the loop work. They're forced to care by the curriculum and the teachers, and the teachers have to tick the box to say, yes, they've understood loops, yes, they've understood variables, but the kid wants to play the drums at the same time as the kick drum. That's all they care about. And so this is a problem. So I would say to the teacher, okay, this was a learning opportunity for teaching loops. Great. But how do we get the kid to play these two things? We need to introduce the ability for two loops to happen at the same time. And in programming, that's called threading. And so I'd like to teach the kids threading. And the teacher would say, that sounds great. Yeah, let's definitely do that. But where is threading on the curriculum? I'm looking, it's not there. We've got conditionals, we've got sequential programming, we've got functions, we've got variables, we've got algorithms, what on earth they are, all these things, but not threading. And so when I told the teacher this, and she went, I'm sorry, we can't do that. And so you go to the child who's got the hand up, still waiting patiently to play their two loops at the same time, and you say, well, you've got to wait till you're 18. Because then at university we'll teach you this stuff, right? Which is, how depressing is that, right? Because I don't know about, how many of you have worked with kids in code? A few of you. People who haven't put their hands up, there's a real opportunity for you to spend a good portion of the rest of your lives doing exactly that, because it's the most rewarding thing for yourselves and society in general. I really recommend you spend some time teaching children. The things that excite, whatever it is, it doesn't have to be coding, anything. But here, in a programming environment, a school, getting the child to sit down, right, that's hard. Getting them to sit down and be quiet, really hard. Getting them to sit down, be quiet, and do the task you've set them, insanely hard, right? And then once you've got them doing the task you've set them, getting them to feel confident enough to try something you haven't taught them, which is this. No one's taught them how to do two loops. They've just guessed, well, I can do one loop, surely I can do two loops. And they all guess this, pretty much. That's just magical. You've got this child not only focused, but they're asking questions which are meaningful to them, right? This is not on the curriculum. This is not what the teachers asked them to do. It's something they want to do. They want to play the bass at the same time as the drums. And so that is such a beautiful opportunity to really engage that child, engage that person, and really crystallize their interest and push them in a really new direction. To then crush their hopes and say, no, you're not allowed to do that, is probably the worst thing you can possibly do. Because now then they're disinterested, they look at their phones or out of the window, and you've lost them. And this is tragic. So this is where, as obviously as programmers, we're all using other people's stuff all the time, right? I'm using a computer which I didn't build. Sonic Pi is implemented on Ruby, which of course I didn't write. But somebody somewhere wrote the loop, didn't they? Well, didn't it just exist? Somebody wrote the loop. And we're using it now. Somebody made a guitar, right? And we're using guitars. Do we stop at guitars? No, of course we don't, right? We go on to violins. That's where of course we keep inventing new instruments. We never stop making instruments. Do we stop at the loop? No, we don't, right? So we think about, like, how on earth do I cheat the system? So this is my interesting thing. Like, if I can have a way where I can just slightly change things. So actually, what I would tend to do is I would give these names. Right? And so you give them names. A live loop sounds way better than loop anyway, right? And then kids have got some sort of, and they can give their own names. And I've seen, people have told me about how children are using their friends' names so they pop up, or when the live loops die, it says, "Thread death, Keith." Ha ha ha, Keith, you're dead. Like that kind of stuff. But once you've got this live loop, now you've got this ability to play them both at the same time. And this is where you pull the wool over the teacher's eyes. The teacher has no idea about concurrency. They don't need to know. The children don't know about concurrency. They don't need to know. All they know is there are two loops play at the same time. So in Sonic Pi, I never teach the loop. I always teach the live loop because it has more power. And of course, also, I can comment. And change the code as it's running, right? So that's the other thing the live loops do, which obviously is not new for you guys, but this kind of stuff, right? And so, but the thing is, I'm not showing you anything new. Clearly, I hope I'm not, anyway. But what I am hopefully doing is showing you how the things you already know can be repackaged, can be distilled down to simple forms that you can use to teach other people. And this is not to say you should all go and use Sonic Pi. Absolutely not, right? Sonic Pi is not, I didn't build it for you, right? And when you look at like the web page for Sonic Pi, welcome to the future of music. I'm not telling you that the Sonic Pi is your future of your music at all. This is to everybody else that doesn't know anything about live coding or code at all. Most people have never seen code. They've never seen code. Never mind live code, what the hell is that? Right, so this is what we're dealing with. And I think when we're in a community which is so beautiful and we're talking to each other so effectively and we're learning from each other all the time, I think it's very easy to forget that we're a tiny, 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 tiny community that still has a real big impact to make. Right? And so we need to be finding ways, I think we need to be finding ways to reach out and to broaden the kinds of people here. And so I think Sonic Pi is one vehicle for doing that. And the side effects of this are beneficial for lots of people. So not only now can I go into schools, but what I've also seen is because things are simple enough, and so there are other aspects as well of lowering the barrier to entry. So far I've talked about language barriers, like how hard are the concepts, how easy they are to understand, how can I make something that would have been 10 lines of code, and knowing about variables and knowing about objects and knowing about initializations, all these things going away. Like, for example, like, any of you who played with Super Collider and made a reverb effect? Yeah? Have you ever done that? None of you. Surely, one of you. One person. Come on, going, two. Right? Well, like in Super Collider or any of these languages, you tend to like do something like this kind of thing. You've got a reverb object, and then I'm going to like play my synth, foo, and I'm going to like pipe it through my reverb. I don't know, some syntax like this, right? Where to teach this, you've got to teach variables, you've got to teach instantiation, you've got to teach what on earth is this reverb? It's obviously not a reverb, it's a thing which makes reverbs, like a reverb factory or something. What on earth is this .new? What the hell is that weird operator? Right, so you've got to teach all these things before they can make a reverb. But then they might make a live loop and do this. And now we've got a memory leak. Because every time around the live loop, we're creating a new reverb, and a new one, and a new one, and a new one, and we eventually have a million reverbs if we run this live loop a million times. And obviously, we can't do that because well before that, the computers died. So this is a problem, right? So obviously, then you've got to have some way of killing R. So when do I kill R? Who knows? And there's lots of ways to think about that. But so in Sonic Pi, the way I solved this was just to put it in a block like this. And let's play beep. So here we have reverb. The reverb is just basically affecting these things here. And again, this was an attempt to make it really simple to teach these effects and ideas, but also in a computer science lesson, where reverb is definitely not on the curriculum. Right? If threads aren't on the curriculum, reverb is not on the computer science curriculum. But tons of kids asked how to make this distortion, how do I make echo, how to make it sound big. And so I wanted a very simple way to go into the few kids ask these questions and just go, try writing that. And it didn't interrupt the lesson, didn't interrupt what the children were learning, but allowed me to keep the children who were just slightly ahead engaged for longer, so they didn't disrupt others, but also their interest kept going. So features like this with effects function is the hardest code I've ever written in my entire life. It's nuts. I'm very happy to spend half an hour to explaining how it works. And even then, I still don't fully understand it, and I wrote it. So it's ridiculous. But what it does do is that complexity is hidden and allows this interface, which is simple, so that it will know when the reverb is no longer needed, and it will kill the reverb at that point. So there is no memory leaks. It just waits for everything to be finished and then kills it off, which is lovely. So these kind of features were there because I wanted to allow children to add effects to their code in a way that didn't disrupt the computer science lesson. But of course then it turned out to be super useful for me, not to have to worry about initializing things, garbage collecting things, destroying things, all those kind of stuff that I had to think about previously. And routing things, like this is obviously using SuperClide under the hood. I'm creating a reverb synthesizer, and then I'm also creating the buses for that, and I'm mapping the buses automatically and then unmapping them when they're no longer needed. So there's a bunch of piping and engineering that goes behind the scenes to make this work, which again, if you were coding this in SuperClide, you'd have to do explicitly. You'd have a lot more power. You could do a ton of stuff that this does not do, right? And that's great. But that comes at a cost of having to write more code and it be more complex. So there we go. So then the side effect of all this, so the other aspects which were really also critical were not just the language features I'm talking about, but also things like how easy is it to install, right? So we all know this Overtone, my previous system, was a nightmare to install. Right? You had to download the JVM, you had to download this thing called Maven, you had to write a script which then pulled all the libraries down. It was just if you were a programmer, great. But if you were a school teacher, no way. I'm not going to read a page of instructions. No. Right? And I have a number of people who just came to me and said, I loved your performance, but I just couldn't even install Overtone. Sorry. And so that was a problem. But also, if you were in a school classroom, like that's not even an option. The school teacher just needs to be able to install it on Windows, right? So it needs to just run. And so the amount of effort I put into making Sonic Pi cross-platform and just work is insane, insane. And I don't want to spend more time talking about that because it's work I've already done, and I'm happy I've done it, but it's no longer needed to be done. But that was also critical. And then also, making sure that the pathway to learning was trivial as well. So having a full tutorial, writing all of that, and making sure the tutorial was built into the system and completely complete, and make sure that there wasn't just a story of how to learn it, but every function has documentation. You can see all the effects, options. You can see examples of how to use it. So every single synthesizer, every single function has documentation with examples that you can look and explore and use. And then having example pieces of music that are in there as well. So I have pieces of music, I can just go and just say, okay, cool, I want to take one of these pieces and start with it. So let's take Re-Res, one of my favorite ones to play with. So I'm going to copy and paste that, and then got a piece of music, great. So I can now start playing around with like taking out the bass drum. Let's make this drum half speed. Change effect, crush, make it twice as loud. Like this kind of stuff, right? You can take a piece and just tweak it and play, and lots of people learn in this approach. So making those things just work is a really important part of lowering the barrier to entry to broaden the set of audiences. And once you can do that, then beautiful things happen. Beautiful things happen. So Finland sent a bus to Africa and taught 2,000 Africans, mainly women, how to code with Sonic Pi. Right? And they could do it because it was free. They could do it because it ran on all the different operating systems they found. And they could do it, the install was essentially there, just didn't have it, it just worked. And they could do it because it was a full tutorial, right? So, and that was beautiful. And so I've met a bunch of these Africans all over the world now, and there's such smiling faces. They're so happy. I mean, let's have a look at one of the examples. Here's a little video here.
Hi, Codmas family. So this is just from Diário, Mozambique, and Irena is visiting us. So after Compass, we've been implementing some trainings on weekends for kids and trying to use Sonify. Right now, what you're hearing is actually a training for girls, underserved girls from the community. They're learning how to use like tech-based kind of trainings from Mozambique.
To see that is the most beautiful thing I've seen. And to have children sharing their work in Africa with children in Finland as well it's a beautiful thing. And to have that as an effect of lowering the barrier to entry is a critical thing. So it's not just about what's good for me as a musician, but also if I can make things simple, it makes my life simple. But also it broadens the audiences and lowers that barrier to entry, which is a critical thing. We've run summer schools with children. We've had tons of children programming and playing, and it's been a beautiful thing to see. And if you just like go to the Twitter accounts, you just see constantly, and this is like keeps me alive. If I go to is there pictures of here we are, another workshop. This is like yesterday of people making music. This is my Patreon thing. This is here at ICLC. People playing Sonic Pi. It's just beautiful to see all these children, smiling faces, parents. I was in, one of the fun things I did recently was to go to give a workshop at the National Railway Museum in York. So here's my ridiculous live coding setup, which I used to do my performances with, which is a whole other talk about what this is and how this works. But this is really about trying not to have a thing which looks like a computer, but also brings in the sounds of external synthesizers. And Sonic Pi is essentially the brain which coordinates all these. And I'm trying my best not to have a barrier. So a laptop provides us, like this screen is a barrier between me and you, which I don't like. I'd much rather have it go away. And so that's why I'm using the tablet. But at this place here, I gave workshops to lots of children. And because it was a museum, and it was also school holidays, the children were coming with their grandparents. So I gave workshops to like 50 grandparent-grandchildren pairs. And that was so beautiful to see these grandparents. Oh, how are you doing with this? What's this music thing? And the children were learning it, and the grandparents were involved at the same time. And that was a beautiful thing to see. And to be able to have that level of engagement and across a broad range of not just genders but ages was also lovely to see as well. And this is a corollary of this is that there was one girl who was super excited, and it's for me when I go to schools, if they're teenage and older, especially with girls, they tend not to be interested, and you've got to fight against a pre-made decision that programming is not for them, which is frustrating. Whereas when you go to schools where the kids are 6 to 11, there's no difference at all. They're both similar. All genders are all interested. And but there was this young lady. She was 14. I asked her how old she was, and I asked her, "How did you get programming?" And she said, "Well, when I think it was 9, 8, I got this Raspberry Pi computer, and I picked it up and I started exploring it, and I just discovered it was for me." And to me, this is obviously an anecdotal piece of evidence, but I've seen it in many different places. I think if you can get people young and give them creative experiences of code, I think that experience, if it's meaningful to them, will last through their entire lives. And hopefully by the time they become teenagers and people tell them, you can't program because you're a girl, right? Hopefully they say, actually, shut your face. I love programming. It's part of who I am. Right? And that's what we want to be able to get to that point of. Does any of this making any sense? No? You're all very quiet. Like, I don't know. But what I'm effectively trying to say is that by lowering barriers to entry, we can make systems which actually can be more effective for ourselves, and we can make our systems more effective for society. And that means bringing a broader range of people, more people who wouldn't typically have started and play with it. And that's, to me, what I think we should be doing as a part of our community. We should be definitely playing the esoteric languages. We should definitely be working on experimental things and not caring about anybody else and just focusing on exploring and experimenting. That's totally important and really a core part of what we do. But I think also we should be figuring out how do we take the things we've done and share it with more people. How do we broaden the audiences? And part of that, for me at least, is how do we demystify all this stuff? Like, so when we're live coding, at least this is what I'm trying to do, is I'm not trying to be a magician in the Matrix, right, where, hey, I can code with a really tiny font and millions of, which is what I used to do, right? I used to do performances with 1 million words, because I've got extremely good eyesight, right? That's great for me, but is it good for you? No. And so by making the code legible and small, or I used to also put visuals in front of the code. That also makes it very hard to read. I ended up alienating a whole ton of people and making it hard for them to understand, to such an extent they didn't even realize it was code. They thought it was visuals, as I was saying before. And so by making things simple, making the fonts bigger, making the words simpler, I was able to reach a broader set of audiences. And also do performances to people who'd never seen code before and get them to laugh when I write comments and get them to focus in when I make the code short and simple and to get engaged with what's going on. That's really an important thing. Because for many people, here's a picture of some code on a screen, that's the standard thing you always see. Where are we going? It was in Karlsruhe a few years ago. And where is this picture? There's my child. There's my life. Yeah. For many people, this is their first view of real code. Right? We've all seen code on the television, haven't we? You know, like we've seen actually it looks pretty similar to the code you use with the spinning cubes and like you've seen like crime scene investigations programs where it's not real. But most people have seen programming, they think that coding's like that. There's that famous sketch, I remember, where this computer system has been hacked. So of course, when the computer system has been hacked, all the windows start popping up on the screen. That's obviously what happens. And so this guy starts to sort of defend against the hacker whilst giving a narrative. Like, oh no, the hacker's through the firewall, they're around the routers, like, as if they're like, taking a journey through a building. And then this other person comes and knocks the first person out of the way, not to take over the code so they can do a better job at beating the hacker, but they take half the keyboard. And the other person has the other half of the keyboard, and they're both furiously hack at the same time. Double effort, obviously, is going to provide twice as much safety. And the thing is, it's a joke, obviously, but for most people, they don't realize that's a joke. They have such a non-knowledge of what programming is that we have to recognize that and remember that. And so, for many people, this is their first, these kind of performances that we do are their first view of actual real code, and that's a beautiful thing to see. And so, we need to be aware of that. And I think also that means that the kind of performances we do now, we should be able to look back in just 2 or 3 years and say, well, actually, that was really rubbish, because what we do now is a bit more interesting. And that's not because you as an individual has improved, but you've brought society with you. You're allowing, like, you want to start simple so the society can to understand it. And then as the society knowledge increases, as we're teaching, as we're getting more people to creatively code, to live code, then we can start to increase the complexity of our systems and bring the audience with us. I think that's, for me at least, that's one of the objectives I have. I don't want to scare people off. I want to bring them in. And I want to be able to make sure that if they like the performances that I do, that they can go home and do it themselves, trivially, like with no extra effort at all. To me, that's really a critical part of lowering that barrier to entry. I think I'm running out of time, but that's really the kinds of things I want to talk about, is that the simple things that I worked on turned out to be really powerful, not just for me, but for lots of other people. I would like to challenge you to project your code on your walls at home when you practice. I challenge you to practice as well. That's a really interesting thing to do. But is this a contentious issue? I know some people are really against practice, but for me, that really changed the way I work and who I am and allowed me to do the things I'm doing now. So maybe it might help you as well. And to try and find people who don't program and get them to work with you, right? So like the Meta X thing, let's to finish off with this. Like, I formed this band with Jonathan, my brother-in-law, and he's a smart chap. He's got a PhD in chemistry. He doesn't know how to code. No idea how to code. And so for me, that was actually useful because I wanted to sit with a person that had no idea, so that I could make sure that it wasn't just a conversation between programmers, it was a conversation of what we wanted to do musically. But it turns out now Jonathan's moved to Chicago, he's now a programmer, right? So he's changed his life because of working with code, seeing how it actually affected him and who he was and how he could express himself. And now he's ditched his career as a chemist, and now he's a programmer. And so go and find people in your lives that aren't programmers or that aren't artists and see if you can find a way to have a conversation with them. Sonic Pi is a great way for some of those conversations, and there's a ton of other amazing tools that are there as well. Now, I'm going to finish off with one sort of treat. One of my favorite inspirational piece of software, which really drove a lot of this focus on simplicity, focus on simple installation, was Thor Magnuson's ICLC. And that for me was like, this is how things should work. I should just be able to download it and run it and just make some sounds. The problem for me was that I had the challenge of teaching computer science. So ICLC didn't really give me the tools for doing that. It gave people the tools for making melodies and rhythms very, very simply and effectively. And so that wasn't really an option I could take. But now I've gone full circle in the sense I built a system for computer science that's now useful for music. It makes sense to revisit that past and think about how do we take the advantages of something like ICLC and getting it working with Sonic Pi. So I'm really excited to show you the very first example of something I've been working with Thor on, which is to implement ICLC in Sonic Pi. Right? So I can make a very simple rhythm in ICLC style and have it. And get it working in the same way. So we could start to play around with ICLC style things. I can have multiple of these going at once. Let's just have this one doing like drums, and this one doing like a bass and or like this. And I have that running with like a live loop. Let's think about what should we do. Arrow vein, beats, and then 4, stretch it to 16, beat 4, 16. So have that sort of. And merge the two together, right? So here I'm using ICLC code, but applying Sonic Pi effects and modifications to it. And I think this actually is a really exciting place for me to be, of taking the musical simplicity and power of an ICLC style language and merging it in with Sonic Pi. So that, as Thor was saying before, you can start with something simple, but then immediately go under the hood and explore the underneath. And so this, to me, is an exciting approach. And Sonic Pi could be a tool for you as well to explore your languages by building your prototypes on top of it. And then when you find the barriers and it's not working how you want it to, then sure, go and spend the time to re-implement it in a more sensible approach that has more power, like Super Collider, for example. But Sonic Pi could be a great way for you doing your explorations. So for me, this is a really exciting future of what I want to do. It's bringing these simplicities together. I'm always looking for ways to have conversations with people about how we can broaden our audiences, make the people we are able to communicate with more diverse in every way we can possibly can. And for me, that's about lowering the barrier to entry. So if you have any ideas or thoughts, please do let me know, and I'd love to have those conversations with you. And I really hope that you can take your ideas, use them to express yourselves, but also use them to improve and empower the communities around you. I think that's, to me, that's where the really exciting things happen. And I hope in 5 years' time, as a result of that, this conference is 5 times bigger at least. That'll be amazing to see. Thank you very much. Do we have time for questions? Is that a thing? Any questions? Hello.
Hello. Just thinking back to one of the papers yesterday also, what about translations? Because all the naming is English, basically.
Translations of the code?
Of the code.
Yeah, that's a really good point. So obviously in Sonic Pi we have a crowd-sourced translation system for the documentation. So it's already in Dutch, it's already in Russian, it's already in Portuguese and Spanish to various levels. And if your native language isn't completely translated in Sonic Pi, I really invite you to help out by going on a simple web page and just doing it sentence by sentence. But the code itself, that's a really interesting and problematic thing. So in Scratch, for example, which is a sort of pictorial language, that you can switch that to a different language. So your if statement is if in your own natural language, or in your own symbol set. So ifs in I and F is not going to be what you write in Japanese, for example. That's totally great, but we can't do that with text. Because, so the way that Scratch works is each of those pictures has a unique identifier that is the name of that thing. The if is not the name of that block. It's just associated with it. It's like a label you can put on, but you can swap it to any label, but the ID is the thing. The if, for example, the do in this, I haven't got control over. It's Ruby. And so to make the language translatable, I have to then write a new language, new programming language for every human language target. And what that means is then, that could be possible, but then you've got to be really careful you don't have any words in language A that are also in language B, but used for different things, because now you're screwed. And then also, how are we going to facilitate collaborations between two nations or multiple nations with different languages? And so having a single language really, I think, facilitates collaboration where African children can make music with Finnish children. And so for me, there's a pragmatic answer to that. And by making it a single language, everyone can get involved. And also then, things like beat stretch, okay, that's English. Amp, that's English. Well, what? No one knows what that means. Or release, or attack, or sustain. No one knows what those words really mean, unless you're a weirdo person like us, who spends time looking at synthesizers, right? So even if the words might be in your native language, they might not be words you know, or might be words you thought you know, but they were used in a different way. So sustain, for example, is an English word, but you wouldn't think of it as the point of the amplitude, which stays the same for a while before we go down. So I think that actually there's a lot of vocabulary which is still to be learnt, even in your native language. Does that answer your question? I mean, ideally, I would like to move to a Scratch-based language and have it do that. And that's another future thing to consider, but yeah.
Hello? Yeah.
Hello, hello.
All right, thank you. It's very nice to see Ixti there, by the way. And,
yeah.
But when we're teaching live coding or programming to students with musical systems, it seems to me to be at least 3 very difficult areas that we're teaching. We're teaching computer science, we're teaching music, and sound synthesis. And they're all very difficult to communicate in maybe an hour session or through 10 weeks or something. And when in environments like Sonic Pi or Super Collider and so on, it all mixes. You're mixing computer science in a loop there. You're mixing computer science concepts with musical concepts, with sound synthesis concepts. So do you find, have you got any solutions to communicate that or teach that or to even teachers and the students, how they can separate what is computer science, what is music, what is synthesis? With, for example, you could highlight the certain codes in certain ways, you know, that you press a button and you can see all the computer science concepts in the code.
It's an interesting question. Actually, my gut reaction to that is I do not want to do that. But actually, now you've asked that question, I would definitely think about it. But the way I've thought about it is actually by not separating them, by merging them together in a way that you don't realize they're there, that actually makes it more meaningful to more people. So for example, going back to the weirdo thing, I enjoyed learning how to program because I just like looking at the computing concepts. I'm a weirdo, right? And when you go into schools, people don't want to sort numbers. Who cares about sorting? In the UK, we had new curriculum work, support work. And one of them was called Have Fun with Sorting. The other one was called Give Binary a Try, as if like once you tried binary. Like, I don't know, for me, like, the raw computer science concepts didn't appeal to most people, whereas the musical ones did. And so by not making that distinction clear, you can go into a class and teach baselines. And, oh yeah, you happen to be also teaching lists and iteration and functions, but they kind of came through. And the more I merge them together, the more I not separate them, I find the more benefits I've observed. But of course, maybe if you're from a teaching perspective and you want to make sure that you've got a list of concepts that you want to teach, musical concepts or computer science concepts, maybe then you do want to be able to pick those out. But I've tended to find that by merging them together, you actually maintain and broaden the interest and the meaning to the people.
Another question on the aspect of teaching, because I always wonder, or to me personally, one of the differences between coding live and coding, let's say, in lack of a better word, is quite often, in live coding, most of things you do have some kind of reaction and you get some instant feedback and some instant gratification, which is not necessarily, it might even happen like what Bob Ross calls a happy little accident, and you might not get the result you expected, but you get a result. And in application development, quite often you sit 2 weeks on the same problem, like making your program work and easy installable, which can be quite a frustrating task, which way delayed gratification. And I wonder, in teaching, do people get past that, or get they sometimes back to you and say, oh wow, you told me programming is simple, but it's so hard, I can't do this anymore. Is this a thing, or do you have the impression that people get past this threshold of instant gratification and start?
It's a really good question. I mean, the work I've been doing is mostly with people who are just starting. Okay. And that's everybody. So whether I'm teaching elderly people or young people, it's the same lesson because no one knows how to code. And so I haven't got that much data really about seeing people going through a journey. And actually, the goal with Sonic Pi is not really to be a musical instrument. It's not really to teach computer science. The goal of Sonic Pi is to give people a very low barrier to entry experience of creative coding that doesn't scare them away. So that's really all I'm trying to do, is just to give them this feeling that actually coding can be fun. Yeah, and then I think that the delayed gratification comes when you're doing like proper programming, whatever the hell that might mean, where you're building Sonic Pi. Yeah, and then you do need like delayed gratification. But I think that's not most people learning in schools at that point. So yeah, but I think that it is a really interesting question, and I think that once we move beyond giving people introductory workshops and move to more advanced workshops, I think that's where those questions happen. But I think those questions then will relate, certainly with things like Sonic Pi, will relate much more back to the musical aspects. How do I make my melody nice or interesting? And those tend to be the kind of difficult questions to ask, rather than the delayed gratification questions. Because you don't tend to build large systems or large compositions in Sonic Pi. At least I'm not seeing. There's a few people who have, but it's not very normal.
Maybe.
Any more questions?
One more question.
No? Well, thank you so much for your time. It's a real honor to be here. I do hope that you carry on conversations with me, and hope we can try ourselves to get more people involved in programming and creative programming, particularly in general. Thank you very much.
Muchas gracias, Sam. Now we will have the poster session. So I ask the authors to stand in front of their posters. And I also am asking everyone to pass by and check and be able to talk with the authors. And then after the poster session, will we have the announcement of the next ICLC conference.
am interested in music and live coding as not music. And specifically, I'm interested in the ways how live coding can be beneficial. So I was reading all of the past papers and going through talks, and I noticed a number of people mention the word meditative when they describe live coding. And that was kind of fascinating to me as someone who does meditation and is on the popular mindfulness train these days. Thinking about how live coding could be part of a mindful life, about paying attention to each moment and enjoying our time. And so what I did is I looked into the kinds of things that would make a live coding experience meditative and what sort of things that might be helpful to let go of. So, for example, there's this idea of musical works that's been around since about the 1800s, and it's actually a relatively new concept in human history, but it's now something that's very well ingrained in our culture. But as a meditative experience, if we're comparing what we are doing to some idealized standard of works or something that has rules or any sort of parameters that we may break or not, then I was looking into some of the research into this that goes back to around the early 1990s, especially a woman named Lydia Gura who wrote a book called The Imaginary Museum of Musical Works, and talking about how the idea of a work actually functions as a regulative concept, as something that dictates our behavior. And for a meditative live coding experience, whether you're a performer or a listener or dancer or someone who just wandered in from the street, the experience could be meditative, and the idea of a work is one of these things that might sort of get in the way. Another idea that could actually sort of detract from a meditative experience that might be helpful to, and I think is one of the interesting things about live coding, is that we already do this, is that we don't think of music so much as a thing that we can hold and treasure, and less about that, and more, to use a word that Christopher Small has used, another musicologist. Well, he's actually an ethnomusicologist, but he used the word musicking to describe music as an activity. So switching our emphasis about talking about music as a thing to music as an activity is another concept that I think could be helpful in cultivating live coding as a meditative experience. And then the third area that I talk about in the paper is roughly this notion of music analysis. And among musicology circles over the past similar period as to when live coding began, there's been a recent interest in the idea of the ineffable in music, meaning music as something that is indescribable. And I think this particular term is kind of interesting because what scholars who are looking into this subject talk about is how the very notion that we think we have to analyze our musical practices is something that could sort of inhibit our enjoyment of the present moment. So there's a focus more on what scholars would call the drastic over the Gnostic. And I mean, it might make a whole conference like this seem silly if we're going to say, well, we can't say anything about it, but there's actually some interesting pragmatic benefits to thinking about a musical practice as something that doesn't need to be analyzed, that we're all just here having fun, enjoying algorithms, listening to talks, not thinking anyone has to do it one particular way. So that's a brief overview. I don't know how many minutes I've gone. That's probably at least 5. So I have 1 more minute to wrap up with some of the discussion. So in my paper, I adapt kind of a pragmatic approach. And there's a lot of interesting philosophical ideas, but I'm interested in how we can relate these to actual experiences. And in this paper, I did it through this notion of meditation. So the idea of enjoying the present moment, of listening to what's going on stage or while you're performing, not thinking that there's a right way and a wrong way. These are things that I've described in this paper in the context of meditative live coding, but really I think might be beneficial in other areas. For example, with my kids, this is one of my inspirations, is that my daughters, I have two daughters, they're 11 and 14, and both of them are very afraid to play in front of other kids. So they think that they have to be doing something a certain way, and I love how the live coding community cultivates a notion that it's okay to fail, that we can embrace failure, that we can just have fun doing it, and that we can enjoy each particular moment. And whether I have a 5-minute talk or a 50-minute talk, you'll never fully understand whatever it is I'm saying, because there isn't actually some essence to what I'm saying. So how meta is that? I'll end there.
Thank you very much. Well, we will continue. Well, in fact, we are discussing if we continue with all the speaking presentations and after that we turn out the posters to see the demos. What do you think is the right way? Poster demo? But we need to see the guys behind the posters. Any ideas? Okay, let's do it like that. Okay, the next presentation is full body interaction for live coding by J. Olaya, I. Zapata, y C. Nemocón.
Vale, thank you. Well, I'm going to talk about my paper. It's called Full Body Interaction for Live Coding. My name is Juan Olaya. So, well, we identified the necessity to integrate the audience in the live coding. Well, we were talking about that, so, and then we decided that integrate the audience by full body interaction. So, in this project, we are using the Kinect sensor. And, well, we developed this matrix that allows control the movement of the objects. For that reason, we are using as well, well, maybe have you heard about Hydra? That is from Olivia Jack. Is a tool to generate the visuals in live coding. And in our project, we are using as well this tool, but we are using as well object-oriented programming to generate the visuals. So therefore, we can control the objects, and we can also create multiple objects, and we can also map these objects with the movements of the user on the mat. Well, so in this map, we can, or the user can, for example, go up, go down, go right, left, and also rotate the objects, change the speed, change the speed of rotation, also change the shapes, and create more objects or delete the objects. So for this project also we are using a module that is called Dosis. It's also a tool that Camilo created. Then we have another paper with this tool. And for this project also we use Super Collider and Tidal for the sounds, and so here we have a diagram, and we can we show the way that we integrate the three tools. So well, in our test, in the first test, we found that was difficult for the user to see the feedback of the visuals, and also was difficult to found the feedback of the sounds, and so we enhance our tool, and then we are going to show how works that later. That's all. Thank you.
De una vez el demo, ¿no? ¿Puedes? ¿Está listo? Vamos a abrir los pósters. Vamos a abrir los pósters. Sí. Okay. Pues, de una vez. Well, now we will continue with this demo.
Well, now I'm going to show just the visuals. Well, we create some classes to represent some shapes. I'm going to play some song from just to make sense. So, well, here, for example, I'm using as well object-oriented programming to generate the visuals. And then I'm going to use these shapes as a source on Hydra. I mean, I'm going to apply the effects of Hydra on these shapes. And that's all. Thank you.
Well, thank you. We will now see the reflections on learning live coding as a musician for M. Cheung. Please come in. And please, Mercury, Hoogland, prepare for the next. I take the.
Okay. All right. Thank you.
Please be consistent.
Sure. No problem. Can I get some light? Can I get some light?
Yes. ¿Puedes poner luz aquí?
Hello, everyone. My name is Mei Cheung. I'm a singer-songwriter based in New York. On an average week, you can see me at a song club or performing in the Lower East Side. I've been live coding for about a year. I was introduced by a couple of friends, and this is a poster on a paper that I wrote about my reflections on learning live coding, coming from a musical background. So the first thing that I noticed that there were differences and parallels, and there's a point in which live coding merges with performance of music. The first difference is the visual differences. With live coding, we use Roman numerals and numbers, keyboard symbols, and in music, it has its own hierarchical structure in which we use symbols and numbers, bar lines, note heads, etc., etc. The second difference is the kind of multitasking that live coding lends itself to. For example, you can play a synth and put some reverb on that. You can change the ADSR with that and choose the notes and play that. So compare that to playing a gig on a regular night. You probably have to bring your own amp. You gotta schlep your stuff all over the place. But with a live coding, you can just bring your laptop and you're good to go. The third difference that I noticed about live coding and playing music is that there's this sort of practical application that live coding allows you to do. So the example that I have here is a reggaeton beat, which ruled all of radio airplay for 2 summers in a row. And it's a 3-3-2 rhythm over a 4-on-the-floor beat. And I basically just created a live loop here with snares, and then a 3-3-2 beat. And I defined the S here with 0.125. So that's the number there. So you can use live coding for so many rhythmic possibilities. So you can do 5/4 or 5/4 over 4. You can just do so much with it, and it's not too hard to do. You just replace a number with another. The fourth difference that I noticed was the type of artist-audience relationship, or lack thereof. Through performing live coding, I have noticed that there's not too much human contact, eye contact, or any of that. And it's not any of our faults. It's just the medium that we use. We have a laptop in front of us, or we're sitting, or standing. And I didn't make it to the beginning of the conference, but I heard about this one woman that was talking about it. Okay, so I'm going to move on really quickly. The parallels that I see, when I code, I think in a musical way. So this is what I see in my head when I am live coding this. I also, when I'm live coding, I practice and I memorize and I test. That's my method of performing live coding. And lastly, the one instance in which live coding merges with music performance is the one instance is when I saw Anne Weinberg perform her Claude Clavier project with Felipe Ignacio Noriega. So for just a quick little example, she plays da 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 da, and the word hello comes out, and she uses her piano as an interface. So that's about it. You can feel free to come up and chat with me after. Thank you.
Thank you very much. Sorry for being hurried, but we are a little bit late. The next is Mercury, a live coding environment focused on quick expression and communication by T. Hoogland. Thank you.
Timo Hoogland. Yes. Hello, everyone. I'm going to stand over here so everyone can see me. Right. So my name is Timo Hoogland. I'm from the Netherlands and fairly new to the live coding community. I've been live coding for a year right now. And before that, I've been doing algorithmic compositions, audio-visual compositions with Max MSP for like 5 or 6 years. I started live coding with Max, like actually live patching. I found that pretty tedious. So I thought I want to design my own live coding environment, which became Mercury. And it's completely built in Max, so it's on top of Max MSP, as you can also see over there maybe. And the whole idea of the environment is to give me the tools to compose quickly on stage, both with instruments also, but also with rhythms, melody structures, and I do that by allowing for multiple functions, like reusing lists for different octaves. So I decoupled the intervals and the octaves in the note function, so you can also declare the interval and then separately declare which octave it is in, so you can reuse lists over and over for various instruments. I have incorporated the sync to skill function, so you don't need to actually know what notes you want to use. Just make a random list, sync it to a skill, and all the values will map to the closest value that's in the skill. The code is continuously running a loop, so you don't have to declare any loop. If you use the time function, it will just fix it to a certain time interval. I will keep it short and maybe get... Right, so I also want to say that I want to keep transparency towards the audience by using full words as much as possible, no abbreviations, stuff like that. And also keeping the text as full as possible to the size of the screen. So it's auto-sizing while typing. And I limited the lines of code to 30 lines. So if you're at the bottom of 30, you have to delete your code if you want to make something new. So the audience is always totally reading everything you're doing. And the rest is hidden in the software. I wanted to do a live coding demonstration, but I have a video prepared because of the time. Enjoy. There we go. This is actually speeded up. Okay, that was it. Thank you. If you got any questions or want to talk about it, please come to me, and I'm glad to maybe also show it on the computer, see how it works in Maximus P as well, if you want to see it under the hood, no problem. Thank you.
Thank you, Timo. Now we will see Dosis, processing live coding interface by Nemocón. And please, the last one, Suslov, be prepared.
Hi. My English is very bad. For this reason, I need to read the translation of Google. I'm sorry. All right. This is a Dosis project developed by Laura Zapata and Camilo Nemocón. This is an interface to use interactive devices like Kinect, Arduino, joysticks, with control, and others type of controls to using live coding. Dosis have two interfaces. One of these is like this, and in this interface, you can write the code and send data to Arduino, tracking the body, and send this data to Super Collider and write code to create visuals in this canvas. Dosis allow that any person can, as a part of the performance, not only the coder. Any person can use the Kinect or use other game controls or other interaction device, and can interacting with the coder to create a music performance.
Hi, sorry for my English. In addition, the challenge was to make an interface with idiomatic, with the practice, with live coding practice and the compose. And for example, with the Keynote, we adopted the similar system such as theremin. Yes.
We show you a little demo. It's very short, no problem. sorry. The idea is that you put the code and real time turn on the things of the Arduino and move this box. And with this sound, you can make a melody using super collider. And
Thank you for the demo. Now we will see the last poster by Suslov, sorry. Is LiveCoding.space toward P2P collaborative live programming environment for WebXR. When you are ready.
Hello, and we have a demo of our system, and Tanya Sashenina will help me and assist. So it is the second time of me in a LiveCoding conference, and actually when I come to this conference, I come to LiveCoding from computer science. And actually we're all speaking about tools, and SuperCollider, SonicP, and other tools. And on this conference, which I found really useful for me, for example, that a lot of papers were about languages, and we need languages, our domain-specific languages, and we need to introduce it by ourselves. But my history and this open source project, which you look, it is about virtual world, and actually it is about how we could go out of tools. So we introduce, like, virtual world introduce a notion of mediator like an avatar. And so we think that we could create such an environment which will be very easily, how to say, runnable on every device, just from headsets to computer or just phone. And it could be highly secureable, that people could register just by their own and without any central authority. So we use again to be distributed storage system for that, and P2P identities, and also that it could be reprogrammed just when it's running in the browser. So it is a sub-project of Christiansta project, which was actually some experimental software based on Crockett architecture for collaborative stuff, which run on Smalltalk language. So, and now I'm going to the demo. Now, we will just show you a little experiment which connect two devices, one computer and this headset. I just checked it. Let's see. Okay. So we'll try to run a demo from internet. So there could be some lags, but actually this site is formed from these components or prototype spaces. We start from collaborative orchestra. So when I start, I actually start one instance of this one virtual world. And to this instance, Tatiana will connect from her device. So in device, she get a link. Tanya, are you seeing a link there that you could prepare? Okay. So we could just, and we are waiting for her avatar to appear. Okay. So we'll get it? Yeah. So now we have a simple, like, orchestra. We send OST messages, we connect to local relay or relay, and I just connect to this. Okay. And in Sonic Pi, just again, a simple, like 2 sample channels, 1 synthesizer to run. Okay. And now Tanya come to these two instruments that I could see the code of them. If I go to the scene, I could actually find them. They are real, for example, one, and open a method browser here in browser, and to see what happened when it starts. So it triggered a sample, And for example, if I say that drum house, yeah, no. And please, Sultan, please. Please, nothing happened. And another. So now I try to start a sequencer, a little sequencer. And what is specific to virtual world? That virtual world you can run an environment and simulators. And for example, this one, for example, this head, I just turn it off or turn on. Okay, I turn off it, and now we are concentrate on this instrument, on plug instrument, and now I'm going to reprogram it. So I go to Meta browser and for this instrument, synth. It's just JavaScript here, but on Meta or on language, so it's just to make an API is easier, but I just show the prototype. So I just changed the node, but for example, I could create the new method which will run a simulation. Run method. And so what this method will do? For example, this object rotate by, for example, 5 degrees on Y, and then do this, please, in future. For example, 0.5 of virtual seconds. I save it and start. Okay. So you see this? I just so it's running now, and now I'm just sorry for late. So just take some sample. Sorry. I just want to show you how the simulation just starts. So please, I'm just stop the sequencer, not to we stop simulation, but now I just show you that instead of the messages, I will send the position of. So that's it, and this. Cheung. And now, on every tick, I will set this message. So I could remove that. And now I could update the method. We'll start. So you understand the idea. You could actually, I could just take an avatar position, an avatar joysticks, or somebody could say an iPad, and they could in publicly use this way. So again, so Tanya, we finished this experiment. The next experiment, just to show. A demo, it will be like for example, we want to use an AR markers. So I will be in AR mode, and Tanya will be in edit mode. So she will add a new stuff. How much? One time? Oh. So it's very. Oh, it's me. So I just put it. Sorry. create something. Yes. Actually, this one. Right. So it's just a simple object from a greeting card like, but it's also from visual space. And Tanya now will connect to us, and we will see her here on this card. And actually, all objects which she will put, we should see. Tanya, I'm connecting. Something wrong? Nothing happens. You're connected not to us because you need to have a link. So another just a few seconds, I will show you while Tanya is connecting. We are easily making a cover system, like for example, with several phones or iPhones, or maybe several projections, like this one. So it's the same space, but running by phones, iPads, and so you could stack it together and have such style of cover. For example, it's very useful for, again, for open public like installations when you need to interact with the audience. So to make real interaction, when not so that you could plan a little scenario, not actually to the whole live coding, but the audience could easily something to do, and you could plan it with it. I think so. Sonic P or Super Collider going or some messaging is really hard maybe for this browser and relaying. But if you have a Tone.js or Jibber, for example, so it could be just do the work for live coding in the browser, music live coding. So we have your avatar. No? Please. This moment. Yeah, this one. Just a moment. You could find in paper the details of all internals. So, and you could try. Oh, it's here. So she created an object, and objects just appear. And could you please change the color? Look at this one. It's the same. Big one. Okay. So, and if you come to this space, for example, from your phone, you also could see this. Just so. Okay. Thank you very much.
Is this working? Okay. Well, thank you very much to everyone. I will let you with Giuseppe, who is going to announce the next ICLC venue. And after that, we will have the last concert and the official closing act of the ICLC, of the fourth conference of ICLC.
Giuseppe. Well, oh, it's loud. Well, first of all, given that this, what we just saw was one of the last presentation, then there's the gig tonight and the party, maybe a big applause to this committee and international committee for this year, before announcing the next one. Yeah? Woo, woo. All right, I'll be brief. I'm delighted. So my name is Giuseppe Torre. I'm Italian, but ICLC 2020 won't be in Italy. It will be where I work and live. So where that is, it's on planet Earth. So, well, some of you know already, we had a chat throughout these days. Anyway, next ICLC 2020 will be in Ireland, Irlanda. So, just to give you a little background, I work at the University of Limerick, and then you may wonder where the hell is Limerick. Nobody knows, but that's where it is. So. It's in Ireland, that's Ireland. Many of you are familiar with Dublin, which is there, but Limerick is here. It's on the estuary of the Shannon River. Maybe some of you have heard of the Cliff of Moher. Yeah, so the Cliff of Moher are here, right? So we are on the west coast of Ireland. So I'll show you just briefly the campus, which is a phenomenal campus, like very nice. It's in the middle of a park. So this is the aerial view. I'll just skip ahead. I won't bore you with these long, drony pictures. This is all the Irish World Academy of Dance and Music, Research Center, Sports. It's a campus that is famous especially also for sports sciences, where all the national team across all kind of sports come and train, and where there's lots of facilities in that regard. There's the Shannon actually going through. I come from the Department of Computer Science, and we are basically, this is Limerick City instead. I belong, together with a friend of mine, should be here. Nick, are you here? No, still at home sick. Long night. And we belong to the kind of media side of the house of the computer science. So there are our colleagues, which will be traditional computer scientists, and then there is us, which we deal with arts and technology, art and coding. One of the modules, for example, I teach is live coding as well. So that's the city. And yeah, that's it. Just really looking forward to see you there. So this is my email, or Nick email. We will be the two main people in the local committee, but we will be supported also by many, many other colleagues and friends, and also by the International Steering Committee as well. Yeah, Ireland, Irlanda. See you next year. Thank you. Thanks to the International Committee for selecting Limerick as well. We're delighted.